Thank you very much, Kadir. Let me share my screen first. Uh, I I mean, much of what I'm putting together in these slides, I've also gathered from various sources and I'm putting together. So, um, there's yes, there is knowledge, no doubt, but much of it I needed to consolidate while I was putting all these together. So last week we were talking about microservices and design patterns in microservices. So modern microservices have you can look at design patterns in Azure. All of the ones that are listed on the left, the ambassador pattern, the anti-corruption layer pattern, the async request reply pattern, and the backend front ends. All these are very the circuit breaker is a very important one. Command and query responsibility separation, that's another very important one for databases. Similarly, in AWS also has a similar patterns. They have slightly different way of looking at it, but they also have a lot of patterns. This is where we left last week. So how do we approach database? I'm sorry, microservices as conceptually is this. So you could have the application is already modular, but the database is monolithic. So this is very much happens when we are starting to migrate our application to microservices. So I've just put together a very arbitrary business domains for a business. Some business has a catalog domain, an order service domain, a wish list service, and a layaway service. And these are four components of their application, but the databases, they all share one database. So one of the first things to do would be to separate out the databases such that each service has its own database. You don't mix up the databases. And this is very much very easy to accomplish when we use cloud computing, or even without cloud computing, if we are able to use different databases for different functions or different services. And some of as in the diagram, some of these could be relational, some of these could be non-relational, NoSQL databases like MongoDB or CosmoDB or Cassandra or something like that. There's a very important concept in microservices called domain-driven design, DDD. So again, coming back to this diagram, you have a catalog domain, order domain, wishlist domain, layaway domain, and an API which through which you access each one of these domains. The domains themselves will have subdomains. So each domain would have multiple subdomains, each one of them representing a microservice. And
Partha, what is the domain? What is the domain?
It's a business domain.
Is it like a function, like a billing, like that?
Yeah, so billing also is a domain. Returns would be another domain. It's a business domain. How do you deal with returns?
So
What?
is it like some code that I write to take care of billing is nothing but a microservice, nothing but a domain? Is my understanding right?
The domains are business domains.
Okay. So
not code domains. So within a business domain like catalog domain, there would be multiple sub functions, business functions, which will translate into business into code microservices.
Okay, got it. So this is a domain, and within this domain, different, like for example, billing means I send invoice, and there's different activities that I do, and each
Yes.
of these activities can be written as a code. In other words, as a microservice.
Correct.
Okay,
So
okay, got it.
if you have a billing service, then you could have something that says which invoices have not been paid for 1 month, and then you send out a dunning letter. That is a completely separate function than taking the paid invoice and feeding it back into your accounting system in accounts receivable, right? Balancing the books in accounts receivable. So these two would be two separate functions within the billing domain, and they would be implemented by completely separate microservices. And each of those microservices will be looking at completely different databases. They will be actually calling other microservices. As I said, if you have received a payment and then you want to push it back into your accounting system, you will be calling another microservice that will actually be writing into your accounting system, accounting database or accounting system. So
Pretty clear.
uh,
Thank you very much. Yeah.
yeah, so there is, I mean, in a previous slide, I also mentioned that business domain knowledge is very much important to actually divide something up into microservices, or to actually even recognize this should be treated as a microservice and should be coded as a separate entity or a separate unit of coding. So and so you have subdomains, and then each one of these microservices is what is called a bounded context. So partition the application based on domains that align with business function, right? And then identify the subdomains. What are within each domain? What are the smaller functions that need to be met? And only one of them should actually write to the database. Every one of them should not be writing to the database generally, but it could happen. But generally, no. Identify the scope of each subdomain as a bounded context, and developers and users must share a common understanding. That's where the business domain knowledge comes in. You as a developer, or I as a developer, must talk to the user and understand and have a common understanding of what these are. And each microservice will only implement a specific subdomain. And how does it declare its boundary? It says a contract. There's a design contract, you could say, or an operation contract, and it will be implemented as an API. So that's domain-driven design. And each database is private to a service, so there is no shared data between different domains. At the end of the day, if a service in one domain requires data from another domain, it will request the data from this microservice that actually can fetch the data or write the data to that particular database. So there are some patterns that have been recognized. So we again see the anti-corruption layer that we saw in the Azure slides. So these are things that you need to understand. What is a shared kernel? So you could have two different services, microservices, reading or writing from the same database. That would what would be called a shared kernel. Customer supplier. So if one microservice requires data from another database that belongs to another microservice in another domain, then the one requesting the data would be the customer, the one supplying the data would be the supplier. So that's another pattern. Conformance pattern is you don't define your own data model or object model. You just conform to some other microservices definition of the, like if the most typical is user. The user in each domain would have different attributes. So do you want to write your own user attribute and then because you don't need everything else that from that another subdomain requires. You may require only username and address if you want to send out email address. If you want to send out an email, but some other one may require credit rating, order history, and all that information. So would you want to write your own, or you want to just use somebody else's definition and just use it? So that's a conformist. Anti-corruption layer is again another pattern. There are separate ways. Is two microservices having not having any common understanding of any particular entity, they go their separate ways. This is a very uh, risky pattern. It's actually in some texts you will find them as anti-pattern rather than a pattern. So, so there are various patterns in published languages. A common understanding between different microservices is what is being published. So, there's a bunch of references I've given here. Many of them have a lot of other information and more in-depth information on how to go about these. And at the end of this presentation, I will be sending the slides out so that they can be posted on in Testoper in the files, and encouraged to go and have a look at this. There's a lot of things that are the more you one understands, the more one can do a better job at actually developing applications as microservices. So we keep hearing this term API gateway. API gateway. What is an API gateway? So looking at this diagram, we see that you got an application consisting of multiple microservices, and then you have a web app, which is the front end for the application. And so any request that comes into the web app goes to microservice one. The microservice one has to do an authentication or authorization, and similarly for each microservice. So you have the same authentication authorization being done by multiple microservices, which is not an efficient way of doing it. So this is a cross-cutting concern, what is called a cross-cutting concern, and should be extracted into a separate service, and this will be implemented as a API gateway. So if you look at what happens in an API gateway, this is what happens. So the API gateway will extract the authorization authentication service, and that will be the where the request will go from the web application. The request will first hit the API gateway, and once it's authorized, then the microservice will be hit. So there are many other such cross-cutting concerns. This authentication is not the only one. So static content. Suppose you have web pages that are static content like about and the customers and so on. So those static contents need not be within a microservice. You can have it extracted, put out into a separate store, which can be served directly through the API gateway. It doesn't require authorization authentication. Static content, generally, if you hit any website without even before you even log in, you get some pages. Those are what is called static content. Response cache is when you want to sometimes some parts of the response from your microservice can be repeatedly requested by next calls that go to this to the application. So you cache the response for some time so that it can be quickly served up instead of going back to the microservice. You can you can get it in your cache. There is an aggregator. Aggregator is one request may require response from multiple microservices, which has to be composed into a response stream and sent back to your web application. This function can be again put together in the API gateway, which does all the multiple calls, composes the response, and sends it back to the web application. All these things are ways in which the microservice itself can be made agile and more responsive, faster, and the whole application can take many more requests. But it does put a lot of pressure on the API gateway. The API gateway must be really uh, designed well and have enough compute power to do all this work and still be fast enough. Okay, race limiting is a function where uh, the API gateway will act as a throttle. If there are too many requests, like the Australian Open just finished. So if you actually look at the tennis website, there would be millions of hits on the tennis website. So people looking for scores, people looking for whatever content requires. So race limiting is when the API gateway is able to throttle the request stream so that the microservice doesn't get overwhelmed. So all these are the last thing. The throttling is from the race limiting. Okay. The other concept that people throw about, the word that people throw about when we talk about microservices, is service mesh. What is a service mesh? Okay. So each one of these is a microservice. There are two microservices you set up, then they have to communicate with each other. That's how the response to the client is sent back. Then you introduce a third microservice, and then the third microservice needs to talk to both the first and the second. And then you introduce a fourth microservice, and then a fifth, and then a sixth, and so on. So the more microservice you introduce, the more inter microservice communication needs to happen. And this is, this is so each microservice is running in its own container. It has its own IP address. We briefly discussed this last week when Shravan asked a question about, how do they communicate. So how does one microservice know where to find the other microservice? That's the question. Hard code the IP address? That's not a solution, because when the microservice restarts, it will get a new IP address. And you can also have some items called named services. How do you put an IP address on a named service? Because the named service always has a floating IP address. So this is Linkerd is one service mesh available there, out in the world. You get a non-paid version as well as a paid version of this. And the founder of that product says the service mesh is a dedicated infrastructure layer for making service-to-service communication safe, fast, and reliable. If you're building a cloud native application, you need a service mesh. Even if you're not building a cloud native application, if you're building a microservice application, even in your on-prem platform or cloud, you still need a service mesh. So service mesh typically will consider of a service registry, where any microservice is set up will register itself, and any microservice that needs the services of another microservice will look up in the service registry the location and how to reach the other microservice. So microservice to microservice communication, you need to have resiliency, retry logic. You try to talk to a microservice, it is for the moment down, then you need to have some retry logic in it. You need to have some traffic management. So a microservice may be set up to receive so many calls per second, and so there must be some throttling mechanism to manage the traffic. Observability. This is something very important. One request from the end user can actually flow through multiple microservices before you can compose a response and send it back to the user. Something fails in between. How do you know which microservice at which point did it fail? That's the observability. You must be able to trace across the full path traversed, right? And then logging is another concern that is for every microservice. And security. So MTLS is internal TLS. So when you look at uh, all these concerns that a microservice has to address, there is a piece of code you have to write for every microservice that does all these things. And that is here in this diagram, it is shown as a separate box here. So every microservice will have some piece of code which does all these things: resiliency, traffic management, tracing, logging, security, and so on. Because even between microservices, when you are communicating, you must have some sort of TLS. So some sort of security mechanism in place to understand that the microservice is authorized to make this call. So what happens if we add these extra code libraries? If you're using resiliency, you may use some third-party, piece of code or piece of software to actually logging. Same thing. You may use some logging mechanism like Kibana or Grafana or Elk Stack or something like that. You'll have to push that code into the microservice if you want to load the microservice with the same with all these things. So we will be bloating each one of them. What do we do in such cases? Maintenance also is a problem because every time you need to modify this microservice, you will have to, you run the risk of damaging this code here or making some change that affects that. And the design does not scale well also. So, and service discovery is definitely not resolved by any of, but this is what we are doing here. So that's why the service mesh was introduced. And the service mesh consists of a control plane that is shown at the bottom here. And all the code that needs to be part of the microservice functioning is written as a sidecar, what is called a sidecar. So microservice A does not directly communicate with microservice B. If a microservice A requires some information from microservice B or some function processing from microservice B, it will pass it to the sidecar. The sidecar will look up the service, do all the security mechanisms, call the other sidecar proxy, and then that sidecar will request from the microservice B and then get back the response all the way back. So this whole thing is what is the function of a service mesh. Service mesh will have a control plane and a sidecar, and you put all the code that you require into the sidecar. And the sidecar is a separate entity. It does not change along with the microservice, any changes to the microservice. So whenever you rewrite the microservice, you never touch the sidecar proxy code. The sidecar proxy code is only touched if any one of those functions that we saw before, there is a change to them, then you have to modify that piece of code that is in the sidecar proxy. So you can explore more about sidecar and service mesh and such things. There are some references given here. So these are some of the Istio and Envoy, or the Istio is the service mesh, Envoy is the sidecar proxy. Kong is another such mechanism. This Istio and Envoy are from Google. Kong is from HashiCorp. Consul and Linkerd are from another that Morgan guy. So that's the end of my presentation on this. Let's go to page up. So open to questions now. Do we have any questions in the chat?
Partha, I think it's very clear, right? So API gateway is to kind of, not have the two microservices talking to each other, but through the API gateway. And service mesh also is kind of doing not talking with each other. How this API gateway and the service mesh both come together?
Yeah, that is, many people have sort of combined the functions together, or many products have some combined the pieces together. So you have each microservice will have its own mini API. So the API gateway is you can have a API gate. Um, you can have API gateway doing some functions and the service mesh doing some other functions. So service mesh is primarily will be responsible for inter-service communications and act as a service registry where all services will register themselves. As soon as you deploy a new service or redeploy an existing service or replace a service with its new version, it has to register itself with the service mesh control plane. So API gateway would probably, I mean, still is used, but its function will be limited. The authorization still will happen as the API gateway. The static content will still happen at the API gateway, and the caching will still happen at the API gateway. The throttling now no longer is API gateway function. It will happen in the sidecar. The sidecar proxy will do the throttling. Tracing and traceability and logging will be shared between the API gateway and the service mesh. So various different instantiations or products do things a little differently. The division of responsibilities between API gateway and service mesh. So it's a long discussion. So when somebody is actually trying to deploy something, they have to decide on what they are going to use as API gateway and what they're going to use as service mesh.
Got it. Clear. It's a overlapping. Okay, got it.
Yeah, there are.
Yeah. There's a question from Jeshreet in the Microsoft Teams, and her question is, or his question is, the database in each domain is independent. So, does that mean the two databases accessed by two different databases accessed by two different microservices?
Domains. No. Basically, there was a slide where it showed different domains, and then each domain had its own database. So my question was like, so we have changed the one database system into multiple databases, and each domain has its own database, and those databases don't talk to each other. So is that correct understanding?
Yeah, that is a correct understanding. There is a whole book that has been published that is called Refactoring Databases.
Mm-hmm.
Okay, so this huge corporate database that is a huge, a big schema with every piece of data that the organization is capturing, put into one database with one huge schema. Those days are, that's being deprecated actually today. So each service or each domain should hold only the data that it requires for its function, and should only read and write data that it requires. There definitely will be data that is shared across all the microservices. So, or all the domains, in fact, you may still need a central database, but you will not, none of the microservices will, so there will be another microservice or in front of that database, which will be the one that is responsible to read or write from that database.
Okay. And why do
So
we do
trying
this?
to
It's
slim
like,
down all these databases so that they are no longer, you don't have a dependency on a huge monolithic database. Yeah, go ahead. Your question.
no. So so basically, this is done to reduce the time which is taken to talk to these, like the one big database will take a bigger, longer time, and then individual these small databases will take a lesser time.
Definitely, that is one. Agility, I mean, speed is one. Agility is another. If you want to change something in a database, if you have one corporate database, to change the schema of one corporate database, you need to go and talk to the database administrator, and then change the whole schematic. The change management for that will take months. I
Okay.
mean, at least a month.
Yeah.
In a typical large database like Oracle or DB2 or MySQL, or it's going to take at least a month, because the amount of number of people who have to agree to the change, and then number of people are required to implement the change. You have to have a maintenance period or upgrade period. Everything will be shut down. The database, somebody has to do a huge number of tests before you can declare that the database schema change has occurred. You lose the agility of quick changes. So that is another reason they are refactoring the whole concept of large corporate databases into domain databases, which are only relevant to that domain. Okay.
Okay.
They're still, like let's take a bank. A bank, you still need a customer, basic customer information stored somewhere in one place, in one database, which is central, because the customer ID will be required by every microservice that is actually dealing with anything non-trivial. So, but let us slim down that data that would just have customer ID and probably a few pieces of other relevant information. What is the customer's balance in his account? That should not be in the main database. That should be in a database that deals with the money part of whatever they are dealing with. What is the mortgage he holds or he or she holds? That again will be a separate. It shouldn't be in the central data. There should be no central database that stores this. It should be in the function that does this. Yes, these they still will be SQL databases, because some of the databases need to be SQL databases, because you need some solid schema and some solid way of querying, and you need a solid way of ACID transactions against the database. So you still need all of that, but you don't need a humongous database that is very difficult to manage. Changes to it are really problematic. Schema changes are not easy to do and require a lot of change management around it, and so on. Whereas if you have a small, simple database that is only your microservice is using, the developer can make the schema change and put the schema change into the code base, into the Git repository, and it will undergo some level of overview and quality checks and some level of testing, but it will be limited to smaller databases. I hope that answers your question.
Yeah, that answers. Thank you.
Hi Partha, this is Sean. I do have a question to ask.
Yep.
My question is about the programming language. Is there any preferred language to implement this, or it can be through .NET, Java, and Python at the same comfort, and these services are available and easily accessible by any language?
Yeah, that's yes, you can use any language you like. Mostly microservices are written in the language that that particular team is comfortable with. So all the languages you mentioned are used. Spring Boot. If you want to develop Java microservices, people use either Spring or Spring Boot, because that lends itself very well to microservices.
Right.
Node.js, of course, is always very easy to write a microservice in Node.js. Python also same way. So there will be no central mandate that says you must only use this language for all the microservices in this application. Each microservice is independent. It can be developed in the language that is most appropriate for that particular job it's doing. because all the communication between microservices is still HTTP calls.
Oh, I see. Okay.
Yeah, because they are REST calls using HTTP protocol.
Right.
It's HTTPS protocol, but that's it. So it doesn't matter whether you write in Python or so, as long as your call is can adhere to HTTPS, and you have an API that implements a contract that says this is what my microservice will provide as a function, as functions. That's it.
Okay. Thanks, Partha. That brings on to second question. Is there any standard database? Like, are they equally good to implement Oracle, SQL, Microsoft SQL, MySQL, Hadoop?
I don't have enough knowledge of databases to answer that question. Number one. Number two, it's more of an organizational decision. What database would you, what SQL database you want to use, and what NoSQL database you want to use, because there are many choices nowadays.
Right.
Yeah. So Hadoop and things like data lakes and data sharding of databases and so on are more in the database architecture space. So the database architect has to take a look at what is the total needs of the organization, and then also at the agility and speed, development speed that they are looking for, and then decide on, okay, we will use this type of database uh, across the enterprise for NoSQL and for SQL. They may decide that. NoSQL, more flexibility is there. It could depend on. You could. There are multiple choices available. The most popular one seems to be MongoDB and CosmoDB. So yeah, that's about it.
Okay, thank you.
Okay. The next.
Further,
Yeah.
one question further. So as part of this whole microservice architecture, architecturally, do they have to be on a single server, or when it grows in too many number of microservices, they also land in a different server?
There is no concept of server here. Microservices mostly are implemented as containerized services. So they would be individual Docker or container D type of images, which will be deployed onto a platform that can support that.
So essentially, they all probably will reside on a single physical server, all these containers, or not necessary. Is it not necessary that they have to be on the same server?
No, they don't need. If suppose we are looking at an on-prem system. Okay? On-prem, you could have multiple servers together, providing a common Docker platform.
Mm-hmm.
And the microservices can be on different distributed across more than one server, as long as communication between them is established and the service mesh control plane is commonly accessible by all of them, it should be okay. So
Okay.
you still need to
Yeah,
see. Hello. Yep.
My understanding is that, so my understanding is that, correct me if I'm wrong, right? My understanding is that you have a bunch of hardware, right, which has no knowledge. Then you, on top of that, you have operating system. Then you have Kubernetes orchestrator. Then you have Docker. So all these Kubernetes, Docker, and all these are the infrastructure managers which can take care of the underlying hardware, right? So it abstracts the developer from, once the infrastructure is set up with one server or hundreds of server, it kind of abstracts the developer from really worrying about it, rather than just worrying from the point of view of developing the microservices and for each domains and across domains to really build the end application. So that's my understanding. So long story short, if the infrastructure is set up, with multiple servers, so your microservices can be run in multiple servers. And if it is set up using one server for a small app, it can run in the one server. So that's how I see it, interpret it. Hopefully it makes sense.
Yeah, absolutely. Thanks for that clarification. That's absolutely right. That's so. If you take Kubernetes, for instance, you could have Kubernetes cluster, which consists of maybe 3 master nodes and then 7 worker nodes. Or so the three master nodes will be will be a high availability cluster, and the worker nodes are on which the microservices will be distributed. And through the orchestration Helm chart that you are using, you could basically say how many microservices should reside on each worker. You could put limits on that, so that once you start distributing the microservices, 3 of them, you say that 3 microservices per server per worker node. You could place that restriction, and then the master node will take that Helm chart and implement it by taking microservices one by one, whatever sequence you have dictated, and start running them on the first worker node. As soon as that is full, it will start working on the second one, and so on. Or you could say evenly distribute them across all the service, and that again the Helm chart would do that. You could say, so what is my scaling, and all of that. Yeah, you can orchestrate it quite well with some platform like Kubernetes or OpenShift.
Got it. Partha, we have another 15 minutes. Do you want to go to the next topic, or you want to start the next topic in the next session? What's your thought process?
No, the next set of slides will be is to be a demo by Vikas. Not only a demo, he has a set of slides and demo. So I'll talk. I will let Vikas answer the question whether he wants to do it now or he wants to take the next session.
I have two things, like I have set of slide which will give you understanding of how the cloud work in like nowadays. Like it's more talk about AWS, Azure, and Google Cloud. And another set is it's completely serverless. So it will explain you like one web service with one part of API structure and database call. So just it's a 15 minutes. So like my understanding is we'll go to serverless and we'll start with slide in a next session.
Yeah,
Okay.
yeah, sure. So we have like 12 minutes. Yeah, because we have only 3 more sessions, right? 3 more hours. Within that, you guys have to finish the topics that you have. But yeah,
Okay.
let's without wasting time, let's go quick. I know we have 12 minutes, so you can at least cover the one portion of it today, and then the next portion onwards we'll continue in our next session. Yeah, please go ahead.
Yeah, I'll stop sharing my screen and you can.
Okay, so
yeah, to you.
Yeah, everyone can see my screen.
Yes, we see the mouse moving around.
So like it's a AWS console right now.
It's a black screen. We can't see nothing.
Okay.
Yeah, you have to unshare it and share the whole desktop, because unshare it and show. Yeah, you might have selected only the application.
How about?
No. Do you have 2 monitors, Vikas?
Yeah, I have 2 monitors.
Yeah, so you might have selected the monitor that's not. It's showing black for us, right? Completely.
Okay.
Yeah, now we can see AWS. Yeah, go ahead.
Okay. So I have set up a serverless website on my AWS based on some services. I'll talk about it more in details now. So this is my S3 bucket, and this is the static website. Okay. So serverless is basically like it describes the service practices and strategies that enable to build agile application. So you can innovate and respond to change faster. So suppose this is our web application as at a client side, and this is our API gateway. So here we are using the AWS API gateway service, and then it will invoke a Lambda function, which is written in Python, and it will call external, it will do some action on the external database. And in this case, we are using DynamoDB. So that's basically it. And also, like, this infrastructure doesn't need any underlying architecture. Like, it doesn't need any compute power, and like it doesn't need a static compute power. Like, you don't need to turn on 24/7 a server. So if you call an API gateway, it will call a Lambda function, which is a computer uh, resource. And if it take like just zero point 0.1 millisecond, then it will charge you for only 0.1 millisecond. So that is the biggest advantage of serverless technology. It will only cost for each API calls and only certain time. Okay. So uh, as I said,
So it basically means that we as a developers are abstracted from the underlying hardware.
yeah.
So we don't have to really worry about procuring a server, VMs, or containers from let's say Microsoft, right? So we just use their serverless, whatever the services that they are providing, and we just write our program. We don't really worry about the hardware, what the behind the scene is being used, etc., etc., and we are charged only by the API call.
Yeah, that's absolutely correct.
Okay, just for my clarification, thank you.
Yeah, so with serverless computing, infrastructure management tasks likely like capacity provisioning and patching are handled by AWS, and we don't need to worry about any underlying infrastructure. So we can just focus on business logic and writing the code uh, that server that serves your customer. And on serverless service like AWS Lambda comes with automatic scaling and built-in high availability. So if you have, like, in a normal days you have 1,000 requests per seconds, and suppose on Black Friday if you have million requests on a second, you don't need to worry about if it fails or not. Yeah, it will always work because AWS can scale that service by that level if it is exceeding the request. And Lambda is a event-driven compute service that enables you to run code in response of events from over 150 AWS services. So we have a set of services which provided by AWS. So these are the services. So one of these AWS Lambda, SQS, which is a messaging service, API gateway, which calls API to interact with another functionality or any resources. Cognito is uh, it provides security and logging services. Also, there is a CloudWatch. It's about monitoring. DynamoDB is a NoSQL database. Kinesis, Athena. Yeah, it offers tons of services. But in this particular case, we are using main three services, which is AWS Lambda, API Gateway, and Amazon S3. S3 is a simple storage service. It's it's based on object storage, and in which we can set up a server, a static website. So this is my GitHub link, and here is the wiki. So let's do first functionality, how it works. So this is a static website, okay? And I have one function here, which is the contact form. So if I put my details over here, then I don't have any database or anything in the S3 bucket, because S3 bucket is just like you can say Dropbox. Okay, so I don't need, like, I don't have any compute power or any database storage which can store this data. But if I want to implement this, then this is my static website, and I'm calling a API gateway from my logic, and it will call a Lambda function, and then that will store a data to the database. So let me enter my details. Okay, this is, and so the request is submitted, and let's see how it works in real. So this is my S3 bucket, and now if I'll go to, this is my Lambda, and gateway and DynamoDB. Okay, let's change the. I will give you understanding of all of this thing in our next session. So I have created an API here. It's called put API, and which is invoking the Lambda function. So how it works, this is my client side. It is sending a post request. It's actually options request to the Lambda function, and it will do a query on the DynamoDB. It will run a query on a DynamoDB, and then it will give us a response. And that response is this. Okay. So let's see. So I just call a API, and this is my Lambda function, and it's written in Python. You can actually write it in any language. Like, it doesn't need to be like Node.js or anything like that. It has a bunch of options. You can write your logic in it. So here I use uh, Amazon Boto 3 module to call my DynamoDB, and I pointed to my database. So this is the logic to put data on the database, and then it will give us a 200 response. So which means a successful, like if everything is good, then it will give a successful response. And this is my database. So let's go to tables. Okay, and this is the serverless table. So I just created one query here, and these are my data, which I send it to my database. So this is the description. My email and ID is 85, which is auto-generated, and my name. So if I'll see on the database entry, so here is that entry. So in this whole process, I charge only for minimum amount of time. So if you wanna see that how it works, let's go to CloudWatch. Okay. So CloudWatch and logs. it's actually deleted that logs, but I had another service like that before. And if you see here, the duration is only 425 milliseconds. So it billed me only for 426 milliseconds. So if you run this server like 24/7, if you run this website 24/7, if you have minimum request, basically you won't be charged for years and years. It will be only like $1 bill or $2 bill. So that is the biggest advantage of this for a smaller website. But if you know about Edureka, that is one of the biggest example of a serverless website. So it says that they won't charge a single dollar of amount till 1 year because of serverless architecture. That's the power of serverless architecture. And I don't have much time, but here I will send a link for my repo. And here I have created a wiki. So you can follow these steps and you can create this infrastructure by your own. So you can like do in this week, or we have a study group session. So if you have any doubts, you can ask over there. So this is a small demo. You can follow along. And then if you have any doubt, you can ask me. So like if you want to create a static website on S3 bucket, you can follow these steps. And yeah, it will be good.
This
So,
is really awesome, Vikas. This is really awesome. Do you have like this multiple projects in your GitHub, or this is the first project that you're doing it?
I have multiple projects, but I don't have wiki for all.
Okay. Okay.
But for this specific course, I have created this from scratch, and
Okay.
I have write down like minimum steps. So
This is
like,
really good. This is
yeah.
really good. Would
And
it be okay? Would it be okay for you? You should be having a Testoper GitHub ID, right?
yeah, I do have. I will post in there, and I
Yeah,
will set
it
that
doesn't matter.
test
It
for
doesn't
me.
matter. It doesn't matter wherever it
Okay.
is. You can either post it there, or you can actually create this Codeathon session folder, right? And then
Okay.
you can give a wiki or whatever the notes from there, the link to your wiki for the people to. Either ways is fine, right? It's not at all
Okay.
an issue. Either you can move everything there, just copy and paste, or you can give a link there so people can come from there to here, right? So either ways
Yeah.
is okay. That brings up a good question. Team, whoever is here, do you all have access to the Testoper GitHub? Can you open the Testoper GitHub and show Vikas to the people, please?
Sure. So this is the test of
No,
for
not
Codeathon.
that, I think.
Yeah, here it is.
This is the one, right? So,
Yeah.
yeah. So you see here, we have a GitHub, and those who do not have access to the Testoper GitHub, if you can send a GitHub ID to GitHub ID in WhatsApp or in this chat, we can add you as a person. So here, right, what you can do is because there is a beginner track, DevOps practice, IA track. You can create a new GitHub repository.
Okay.
For
Actually, I
cloud.
don't have permission to do that, but yeah, if anyone can do.
Yeah. So Shad, can you, Shad or Mickey, can you help Vikas on this? So you create a separate one called Cloud Fundamentals or whatever, and then you can, put a link or move this here or whatever, whichever you are comfortable with. Not very particular on that, but yeah. So two things, right? For those people who do not have access to Testoper community GitHub, please send your GitHub ID. We will add you in, and then Vikas, for you, we can make you as one of the admin, right? And you can play around here as well.
Yeah, for
Okay,
sure.
so you can make for Partha, and normally the trainers are given as admins, right? So if you both don't have an admin, we can provide you as an admin, and then you can link it, or you can post it, or whatever that you can do. Okay.
Yeah. So
that was really a very good demo. Thank you very much,
This
Vikas.
is
yeah,
really
sorry, it
great
was
demo.
a little bit quick, but that's it, and I will explain more in the next session.
No,
So
that's why we have something called as study group, right?
yeah,
So you can send this link in the chat. Have you already sent this link, Wiki link, in the chat today?
not yet.
Please copy that and put it in the chat, right? Of the Microsoft Teams. People can really go and look at it until you move, or whatever that you do with the Stopper GitHub, and they can go follow the steps, and they can do it by themselves. And then what if they have any questions, they can join the study group that's happening on Tuesday, right? To learn more from you, right? Because we cannot cover everything in the actual Codeathon session. You understand, right, Vikas? So it's a good one, amazing demo. So last question I have for you, Partha and Vikas. So we have 3 more. This is our 3rd session. We have 3 more sessions. So are we? What are you going to take? And 3 more hours, you should be able to plan accordingly, right?
Yeah. Next session, Vikas will complete his slide deck and explanation of what clouds are, and the 3 different clouds.
Okay.
That I think should take about maybe 20 minutes or so, Vikas.
Yeah, I will take about 25 to 30 minutes, and
Okay.
yeah, because I have some UI demo to show services on various cloud, like
Yeah.
how it works and that. And also I plan it to do some cloud formation templates to and upload it. Then they will see in a real that how it actually works with code as an infrastructure thing. But
Okay.
I guess you are also covering that part. So
Yes.
we can discuss offline and we can decide that.
Okay.
Yeah.
The other 3 sessions are supposed to be on DevOps, completely on DevOps. So each session, what I intended to cover was have a very short, a couple, 3 or 4 slides just explaining the background of DevOps and where it came into place. And the importance of DevOps and why it has become very important today. And then multiple demos. One would be infrastructure as code, just what Vikas said. So there is an infrastructure as code deploying a Kubernetes cluster on Azure. That will be one demo. Deploying a VPC in Google Cloud. That will be one demo. And the third one, Vikas will probably cover things on AWS, because he's the most experienced on AWS cloud. That is infrastructure as cloud. The next will be session will be on Jenkins. So we'll start with how to run a Jenkins on your laptop, and as a Docker container, or even not as a Docker container, you can still run it as a Java program. And then how to have continuous integration, continuous delivery sort of things as pipelines in Jenkins. So how to build a pipeline. And lastly, I want to cover GitHub Actions if we can. We still have time.
Okay.
So that's
So
what is planned for the
what I
next.
can tell you, based on my experience, what I can tell you is next to 3 hours may not be sufficient. What I recommend is Partha and Vikas, take this offline. Maybe you can share the theoretical stuff and some demos during next 3 hours, so you can complete. And the remaining demos, you can request the team to join the study group if they are interested to learn more, so that you both can organize yourself in a way that you can finish it in next 3 hours.
Yeah,
Okay.
for sure. We are always available on study group on Tuesday. So yeah, if participant have any questions about anything, they can ask us.
Yeah. So just make sure that you cover all the topics, demos, whatever you can show, and the details of other demos, you can do it in the study group. What I want to make sure is that before end of these next 3 hours, at least the concept that you had in your mind to cover the end-to-end There's a background noise. I think it's coming from Jaspreet or. Yeah, okay. So what I want to make sure is that as an idea, right, you cover everything that you wanted to cover in next 3 hours in a theoretical way. That's the first priority. And then the second priority is you can show some demos if the time allows and more demos in the study group. That way, you know, you are able to finish your complete thoughts that you wanted to do in the 6-hour session.
Yeah,
That's
sure.
my recommendation.
And just want to make sure, does everyone has access of a study group? So
Yeah,
can
so
we just
they can go to the Eventbrite and they can register for the study group, right?
okay.
And then they can join the study group. Yeah.
Yeah, and do anyone has any questions?
Right now we have 23 tickets out of 25 tickets. I'm going to increase the tickets to 50. So for those who are here who wants to really practically learn, can register them there, right? We should be okay for the demos and things like that. Perfect. I mean, this is an awesome session. Kudos to Partha and Vikas. Vikas, I need you in Testoper project. People need help from you.
Yeah, I know, like from past few weeks, lots of going on production, so that's why I couldn't attend even first session.
Yeah, we need you as a mentor to help the team, right? So when you are available, please feel free to. Okay.
Yeah, for sure.
Perfect. So I increased the number of tickets, so the people should be able to register and come to the study group for the demos and things like that. Perfect, team. So for those who don't have you all should have an access to the Eventbrite or the Meetup. I'm pretty confident that you have. In case, just to help you guys to ease the situation, I'm going to paste the study group, cloud computing study group link in the chat. In the chat for you guys to register and join. And finally, please don't forget every one of you to register for the meetup that's coming on March 20th. So 2 things that you need to register, one for study group, another one is for the Eventbrite. And those who wants to build some awesome products, you can join me in my session on Monday, where Partha and Vikas will also be there. And we'll go from there. Thank you, guys. You have a wonderful Saturday. Unless if you have any questions, raise your hands. Otherwise, we can close the session. Partha, Vikas, are you okay closing the session?
Yeah, we
Yes.
are good if anyone doesn't have any question.
Hi.
Yeah, hi.
So which session on Monday are you talking about? That's what I wanted to ask.
Friday.
Friday. Okay.
Yeah. So the study group is Tuesday. Study group is Tuesday, where study group program, for those who do not know, it's like, think about when we were kids, we used to go to our friends' homes, sit together and study, right? That's what the study group is all about. And that's where Vikas and Partha are leading the cloud computing study group. You can find it in the Eventbrite, register, join to learn. That's number 1. And then number 2 is we have
Friday.
a meetup coming up. Yeah, meetup coming up on March 20th. That link is also available, right? And then in the chat, right? It's called as the importance of AI. And then we have a Testoper project session, which is on Friday. So what about this session is we are trying to help the people. See, there are 2 types of people. One guys are really very good. They can build products and they can build their own company and they can build their own products in the company. But there is a second group of people who wants to learn to get there. And we focus on second group of people to really help them to learn both theoretical and practical, to come together, make a team, and then build some awesome products that you can give back to the community, or you start your own company, right? So that is happening on Friday, Praveen, and the link for that is also, let me post it here. It's Friday 6 to 7. You can join. Okay. Perfect, guys. See, end of the day, we all have to work together and learn together. And I'm looking forward to all your support, registering all the links that I mentioned, and join and help us to, help you to learn, help us to learn, and help us to train, and help yourself to train as well in moving in future sessions. Like Vikas and Partha were attending last sessions, and these sessions, now they are training, right? So we all have to evolve one step at a time. And I have posted the link for projects also in the chat. All right, wonderful, guys. I'll let you go 15 minutes over time. Still, you all are in the call. That shows the interest. of a continuous learning, and I'm very, very happy you are all learning, because end of the day, that's what gives me happy and gives Partha happy. We all are learning together. As simple as that. That's what Testoper is all about. Take care, guys, and talk to you all in next session, whichever session that you are attending. Wednesday, Friday, Tuesday, Wednesday, Friday, Saturday, whichever session you are attending. Take care. Bye-bye.
Thank you, Kader. Thank you, everyone.
Thank
Yeah,
you,
thank
Kadir.
you.
Thanks,
Bye.
thanks everybody.
Thank you. It was a great session.
Thank you. Bye-bye.
Bye.
Because wonderful, Partha, wonderful session, guys.